fake sunrises. Inside a mountain, 20 minutes of darkness with no sky, no horizon, no world above you. And the engineers knew, without something to break the void, drivers would lose their minds. So they built something extraordinary to stop it. Welcome back to the channel. Today we are going inside one of the most ambitious and psychologically sophisticated road tunnels ever drilled by human hands. This is the Lærdal Tunnel, and it is unlike anything else on Earth. This is not just a hole through a mountain. It is a 24.5-kilometer engineered corridor bored through solid granite, designed to keep you alive, sane, and moving, through conditions that would have been considered completely impossible just decades before the first drill bit ever touched the rock. Imagine the challenge. A mountain range so vast, so brutal, so locked in winter snow for months of every year that the road across it becomes impassable. A route so treacherous that travelers were stranded, supplies were cut off, and communities on either side were effectively isolated every time the weather turned. And on top of that, solid rock. Ancient, hard, unyielding granite and gneiss that has been sitting in place for millions of years. No soft ground to ease the digging, no gentle slope to work with. Just raw, compressed mountain, kilometer after kilometer, going in. The engineers faced extreme sub-zero surface conditions, a mountain ridge blocking all overland routes in winter, rock formations hundreds of millions of years old, depths of up to approximately 1,000 meters of solid mountain above their heads, the psychological dangers of long tunnel monotony on drivers, the challenge of ventilating a single tube nearly 15 miles long, the need to remove millions of cubic meters of blasted rock, and the absolute requirement that not a single life be lost in the process. And they decided to build the longest road tunnel in the world. Before we continue, make sure to subscribe to the channel so you never miss a video. Hit that notification bell. We release new engineering deep dives every week. And stay with us until the end, because what the engineers did to stop drivers from falling asleep at the wheel inside this tunnel is something most people never even think about when they drive through it. What if I told you they built fake dawns inside the mountain? At first, there was only rock, no road, no light, no air system, no passage. Just the sheer, unbroken face of a Norwegian mountain range, stretching for miles in every direction. The valley communities of Lærdal and Aurland existed on opposite sides of this geological wall. In summer, a mountain road connected them, a beautiful, winding route through some of the most spectacular landscapes in all of Scandinavia. But beauty meant nothing in winter. The moment the snows came, and in Norway they came hard and they came early, that road closed. And it stayed closed for months, every year, like clockwork. The people living there had no choice but to wait. This was not a minor inconvenience. This was an economic and logistical failure built into the landscape. If you needed emergency services, they were hours away. If you were transporting goods, you were rerouted far out of your way. If you simply needed to get from one side of the mountain to the other, you could not. The mountain owned the land, and the people could only wait for it to allow them through. So the solution was not to find a better road around the mountain, it was to go directly through it. All 24.5 kilometers, from one side to the other, in a straight line under the earth. The planning began long before the first blast. The Norwegian Public Roads Administration, the body responsible for designing and overseeing the project, had to first understand exactly what they were dealing with. Geological surveys were commissioned. Teams of geologists moved across the mountain, drilling core samples, mapping rock formations, analyzing stress patterns deep beneath the surface. They needed to know where the granite was densest, where fault lines might exist, where groundwater could seep through fractures in the rock, and where the tunnel itself should trace its path. The mountain had to be read, understood, before it could be opened. What the surveys revealed was both reassuring and daunting. The rock was, in large part, solid and stable, granite and gneiss of ancient origin, consistent in quality, which meant the drill and blast method could work. But solid rock of that density also meant nothing came easy. Every meter would have to be fought for. Every advance would require drilling, loading explosives, detonating, clearing the debris. A cycle repeated thousands of times across 5 years of continuous work. Construction began in 1995. Teams entered the mountain from both ends simultaneously. From the Lærdal side in the west and the Aurland side in the east, drilling toward each other through the dark. This was not just one tunneling operation. It was two, running in parallel, coordinated to meet with millimeter-level precision somewhere in the heart of the mountain. The method used was Norwegian drill and blast, a technique that Norway had refined over generations of tunneling through its mountainous terrain. Massive drilling jumbos, multi-armed machines bristling with drill bits, advanced into the rock face and drilled a precise pattern of holes. Workers then loaded those holes with explosives. The blast was detonated. The shattered rock, called muck, was cleared by heavy loaders. The face was checked for loose material and made safe. And then the cycle began again. Drill, blast, clear, advance. Drill, blast, clear, advance. Day after day, week after week. Every drill pattern mattered. Every explosive charge mattered. Every meter of advance mattered. Too powerful a blast and you risk fracturing the surrounding rock, destabilizing the walls. Too weak and you make slow progress and waste time. The explosive loads were calculated precisely for each face condition. The drilling angle, the depth of each hole, the spacing between charges, all of it engineered to maximum efficiency. As the tunnel advanced, workers immediately began securing the rock behind them. Raw blasted rock cannot simply be left exposed. The tunnel walls, ceiling, and floor received a systematic treatment. Rock bolts were hammered deep into the surrounding mountain. Long steel rods anchored into the solid rock to pin any potentially loose sections in place. Fiber-reinforced shotcrete, a high-pressure sprayed concrete mixture, was applied to the surfaces, forming a shell that bonded with the rock and prevented falls. Wire mesh was installed where extra reinforcement was needed. In more challenging sections, precast concrete lining panels were installed to create a full structural skin. The materials consumed in this process were staggering. Steel bolts by the hundreds of thousands, shotcrete by the tens of thousands of cubic meters, aggregate, cement, reinforcing fiber, brought in continuously by truck, by loader, by rail-mounted equipment through the lengthening tunnel bores. The deeper the teams went, the longer the supply lines became, and the more complex the logistics of simply feeding the operation. Then came the drainage. Underground rock is never truly dry. Groundwater seeps through every fracture, every joint, every hairline crack in the geology. Left unmanaged, that water would pool on the tunnel floor, freeze in cold sections near the portals, corrode structural elements, and eventually undermine the entire structure. So, as the tunnel advanced, a continuous drainage system was installed along its entire length. Channels cut into the rock bed, pipes laid, collection sumps excavated at key low points, and pump stations built to lift water up and out. In a tunnel nearly 15 miles long, the drainage network alone is an engineering achievement in its own right. And then came the challenge that no purely structural solution could solve: air. A 24.5-kilometer sealed tube with vehicles driving through it produces carbon monoxide, nitrogen dioxide, and particulate matter. In a short tunnel, natural airflow through the portal openings is enough to flush these gases out. In a tunnel of this length, it is nowhere near sufficient. The air must be actively managed. It must be moved, cleaned, and replaced, continuously, for every hour the tunnel is open, for every vehicle that passes through. The ventilation system installed in the Lærdal Tunnel is longitudinal, meaning air is pushed along the length of the tunnel from one end to the other using a series of powerful jet fans mounted in the ceiling. These fans work in coordinated sequences, creating an airflow that sweeps pollutants ahead of the moving traffic and out through the exit portal. But fans alone are not enough. At 3 intermediate points inside the tunnel, air treatment plants were installed. Systems that draw in the tunnel air, filter out particles and pollutants, and either recirculate the cleaned air or exhaust it through shafts in the mountain above. Every cubic meter of air you breathe while driving through the Lærdal Tunnel has been managed by this system. You never notice it. It simply works. Then came the most psychologically innovative feature of the entire project: the turning chambers. The engineers and road planners understood something critical. A 24.5-kilometer tunnel presents a danger that has nothing to do with rock falls or toxic gases. It has to do with the human mind. Driving in a straight, featureless, dark tube for 20 minutes creates a documented psychological state, tunnel monotony, in which drivers' alertness drops, their reaction times slow, and their sense of spatial awareness degrades. They become, in clinical terms, impaired. Not by fatigue, not by illness, but simply by the relentless sameness of the environment around them. The solution was radical. At roughly every 6 kilometers along the tunnel's length, the engineers excavated 3 large chambers, spaces carved out of the mountain far larger than the tunnel itself. Wide enough to turn a vehicle around in, these chambers serve a practical purpose. If you need to reverse direction, you can. But their deeper purpose is psychological. Each chamber is dramatically lit. Blue and yellow lights wash across the cavern walls. The space opens up around you. The ceiling lifts away. For 30 seconds, the world changes. You are not in a tunnel. You are in something that almost feels like emerging into light, a simulated dawn deep inside the rock. Then you drive on, refreshed, recalibrated, your mind reset for the next stretch of darkness ahead. This was not an afterthought. This was a core design principle, the deliberate engineering of human psychology into the structure of the tunnel itself. The tunnel floor was laid with a full asphalt road surface, engineered to the same standard as a national highway, including lane markings, emergency laybys cut into the tunnel walls at regular intervals, full lighting along the entire 24.5 kilometers, reflective markers, emergency telephones, automatic fire detection systems, CCTV cameras covering the full length, and a full traffic management and control system operated from a remote center outside the mountain. Every emergency call point mattered. Every camera mattered. Every fire sensor mattered. Testing ran for months before the tunnel opened. Ventilation systems were run at full capacity, and air quality was measured at dozens of points along the length. Fire response exercises were conducted inside the tunnel. Traffic control systems were tested under simulated incident conditions. The lighting in the turning chambers was adjusted and refined until the psychological effect was optimized. The drainage systems were loaded and checked. Every system was independently verified before a single member of the public was allowed inside. On November 27, 2000, the Lærdal Tunnel opened to traffic. The mountain, which had blocked the road for centuries of winter, had been defeated. The two communities on either side were now connected, permanently, in all seasons, in all weathers, for the first time in their history. Most drivers who use this tunnel today simply see a road. They see lights. They see the walls of rock around them. They press the accelerator and they drive. They do not see the hundreds of thousands of rock bolts pinned into the mountain above their heads. They do not see the drainage channels running silently beneath their tires, collecting the groundwater that seeps through every crack in the granite. They do not see the ventilation fans in the ceiling, spinning continuously, moving millions of cubic meters of air every hour to keep the atmosphere breathable. They do not see the air treatment plants built into the mountain itself, filtering out the exhaust of every vehicle that has ever driven through. They do not see the fire detection network stretched across 24.5 kilometers of ceiling, watching for heat and smoke every second of every day. They do not see the approximately 2.5 million cubic meters of rock that were blasted out of the earth to make room for this road. And they do not see the workers, the hundreds of people who descended into darkness every shift for 5 years, drilling, blasting, bolting, spraying, laying, and building, who did all of this so that a journey that was once impossible could become ordinary. That is the highest achievement in engineering. Not that something is miraculous, but that something miraculous becomes so reliable, so seamless, so invisible, that no one even thinks to question it. Norway needed a way through a mountain. Geologists mapped the ancient rock. Engineers designed a system not just for vehicles, but for the human mind inside those vehicles. Workers drilled and blasted for 5 years through solid granite, removing roughly 2.5 million cubic meters of rock, at depths reaching approximately 1,000 meters below the surface. They installed ventilation, drainage, fire suppression, psychological lighting, and every safety system required. And they did it all without a single construction fatality. The result is 24.5 kilometers of engineered passage connecting two communities that winter once cut apart. And it works, every single day. If you found this video worth your time, please subscribe to the channel. It makes an enormous difference to us. Drop a comment below. Would you drive through a 24.5 kilometer tunnel? Does the idea excite you, or does it make your skin crawl? We read every comment. And if you want to keep going, our next video covers another engineering project that should not exist, but somehow does. Thank you for watching.